Lesson 1.7 is on distributive property. It starts on page 46. We're going to talk first about a definition for distributive property, or kind of how distributive property works. Basically, with distributive property, if there's a number outside a set of parentheses, you can multiply it by the numbers being added or subtracted inside the parentheses. Okay? So a number in front of the parentheses, they're adding or subtracting inside the parentheses, then we can multiply into that. So we've talked about this before. So some examples here. 4 times the quantity, 25 plus 7. We could distribute and do 4 times 25 plus 4 times 7. A reason we might be interested in doing that, 4 times 25 is 100, and then plus 28 would be 128. If you add in the parentheses with the order of operations, you get 32, and you'd be doing 4 times 32, which would maybe be a little bit more difficult problem. Another example with subtracting, if we have 3 times the quantity 80 minus 7, we can go ahead and distribute 3 times 80 minus 3 times 7, and then that would be 240 minus 21, which is 219. Once again, if we would subtract in the parentheses first, order of operations, we would get 73, and we'd be doing 3 times 73, which might be a little bit more complicated problem. In some cases, we are going to be working on problems that have variables, and if there's variables, we don't have a choice. We can't just say, which one do I like better? Do I like doing order of operations or distributive property better? If there's a variable and they don't tell us what the variable is equal to, we don't have an option, and we will just have to use the distributive property. So we look at this on page 46. We're just going to kind of skip over the first part. We already talked about it a little bit. One thing they do kind of in the middle of the page, they give a model that kind of illustrates distributive property. So if you have a rectangle that has dimensions of 8 and x plus 5, kind of what they're pointing out is the area of that would be 8 times the quantity x plus 5. And then they're saying, well, what if we would split it up? If you split it up into, it looks like 2 squares, but if you split it into 2 rectangles, the green rectangle would be 8 times x, and the other one would be 8 times 5. And then if we add those together, that would have the same area. So that's kind of just proving, by cutting this into 2 parts, we didn't change the area. And so it must be that 8 times the quantity x plus 5 is equal to 8 times x plus 8 times 5, which shows our distributive property works. Okay, and again, you could do this with numbers. You could try, what happens if I use the distributive property? Okay, that's 104 versus order of operations. 4 times 26. 4 times 26. And if you work that out, that would be also 104. Okay. So if we look at problem 1, now here come the variables for sure. What is the simplified form of each expression? So if we still have parentheses and we have a number outside of it, and they're adding or subtracting in the parentheses, that's not going to be considered simplified. For simplifying, we are going to go ahead and use the distributive property. So for part A, we're going to distribute here. So it's 3 times x plus 3 times 8. 3 times x is just 3x. 3 times 8 is 24. So 3x plus 24 would be our simplified form for that expression. If we look at part B, This one looks quite a bit different, and I would suggest on this one, you don't have to do this, but since we're multiplying, we can actually use the commutative property. We can change the order of the things we're multiplying. And so actually we can put the -7 in front. The reason I suggest that is that's just what we're more familiar with, is having just the single term in front and then the two terms inside the parentheses second. Okay, so then we would be doing -7 times 5b minus -7 times 4, or however you want to do that. There's different ways with the signs. You can look at that one. But anyway, this would be -35b and minus, this would be -28. We don't want to leave minus a negative. You can add the opposite there, and that's really the same as plus 28. So another variation, if you wanted to, when you were distributing the second part, you could think of it as -7 times -4, which would get you right to a positive 28. Okay. Anytime you have negative signs or subtraction signs, probably not a bad idea to circle those just so you don't lose those signs. So if we look at some problems on the Got It, starting with part A, same idea, we want the simplified form of these. So for part A, we're going to distribute the 5 out here. We've got 5 times x plus 5 times 7. Putting the little arcs there just as reminders to yourself that you're making sure you are multiplying to everything. Again, just an idea that might help you. Anyway, that would be 5x plus 35. And then obviously at this point, those are not like terms. We don't know what x is equal to, so we can't add those together. X could be 0, x could be 1,000,000, x could be -4. We don't know, and so we just have to leave it like that. We look at part B. Once again, we can distribute, so we've got 12 times 3 minus 12 times 1/6 t. 12 times 3 is 36. This 12 we can put as 12 over 1. And then you can either just multiply straight across, would be 12 over 6, or you could reduce the 12 and the 6 by a factor of 6 if you wanted. Either way, when you divide that out, if you didn't simplify, then you should end up with 36 minus 2t. We're going to skip over to part D. Part C, I would recommend pulling that 3 out in front and then multiplying, and you should get 1.2 plus 3.3c. D, similar idea. I would recommend we change the order here, commutative property, pull the -y out in front, and then distribute. So we're going to distribute this, so -y times 2y, and then however you want to do this, I kind of like saying it's minus y times -1, or -y times -1. Okay, so here you can put a 1 in front. -1 times 2 is -2. And then here's the part that gets people sometimes is we're multiplying these. So y times y, we take something times itself, it's being squared. So that would be -2y squared. And then for this last part now, we've got a negative times a negative would be a positive. And then y times 1 is 1y, or just y. So -2y squared plus 1y, or -2y squared plus y would be our answer for that one. Look at the next part. They talk about how a fraction bar indicates division, and so we can use that to make these as distributive properties. So if you look at problem 2, what sum or difference is equivalent to 7x plus 2 all over 5? So one thing to make sure to remember when you're doing these problems is that in the numerator, the 7x plus 2, those are being added, not multiplied. So they're not factors, so you can't do any reducing. Now, I know on this problem we couldn't reduce anyway, but let's say instead of 7x plus 2, if that was a 5x plus 2, if we had 5x plus 2 over 5, you can't reduce the 5's there because it's 5x plus 2. Those are things that are being added together, okay? It's kind of like the idea of if you had, 5 plus 2 over 5, obviously we would just say that's 7/5, right? Or 1 2/5. If you would try to reduce the 5's, okay, again, this is wrong. This is what we're not going to do, but if you would try to reduce the 5's to 1's, you would end up getting 3 over 1, which is equal to 3. And 3 is not equal to 7/5. You can't do that, okay, because they're not factors. The 5 and the 2 there were not being multiplied, okay? So my suggestion when you're doing these problems is to put parentheses around the numerator or around anything that's being added or subtracted. And that's like a force field that says, unless you have exactly what's in these parentheses, you cannot reduce that with something else. You can't reduce that by a factor if it's not a factor. So we can do this the way the book's doing. Another option is we can split it into 2 fractions. I'll show you that in a minute. So what the book's doing is they're saying, well, we're dividing by 5. It's kind of like this in a way. We're dividing by 5. You could put parentheses around that. You could put a 1 in front of it. And then, that's like a 1 over 1, I guess, if you want. And then you could say, basically, as long as we keep the same factors here, we can move the 5 over. It's still the same factors involved. And then this part doesn't have to be over 1. So we could just rewrite it like this. Okay, or you could just think of if you divide something by 5, it's the same as taking 1/5 of it. That's probably an easier way of explaining it. So once they did that, then they distributed here, and then they got this answer. The 7/5 x you can just leave like that, or you can put as 1 2/5 x if you want. The other option you have, I mentioned a minute ago, is splitting this into parts. So if we got 7x plus 2 all over 5, what we could do is if we take each part of the numerator and divide it by 5, then that's okay also. So we could say I'm going to take the 7x divided by 5, I'm going to take the 2 divided by 5, and if you'll notice, that basically takes us to the answer. So that potentially you could argue as being a quicker way. Obviously, this section is all about distributive property, but to me it doesn't matter whichever way you want to work those out. So either you can take the fraction in front and distribute, or you can just split it up into 2 separate fractions. Always with fractions, we want to try and reduce at that point if we can. Those can't be reduced, so that would be our answer. So we'll look at the got it 2. What sum or difference is equivalent to each expression? So we're going to look at all 4 parts here. And like I said, either you can take a fraction in front and distribute, or you can just split it up as fractions, whichever you'd like. For part A, then, you could say they're dividing by 3. Dividing by 3 would be like taking 1/3 of something. So this would be one option, and then distribute. Or otherwise you could, if you'll notice, look back at the original problem, basically just take each one of those terms and divide by 3. So, and you could write this, you can write this as 4x over 3 if you want. Okay. So you go to part B, same idea. We got this fraction that's got kind of two terms in the numerator. We're going to try to write another equivalent expression to that. So if we just take this one and split it into two fractions, we've got 11 over 6 plus 3x over 6. At that point, 11 over 6, I mean, we could change it to a mixed number. We probably won't worry about that. But the 3x over 6, we can reduce that down. And a lot of times, they will go ahead and put the x over to the side. If you do that, make sure it's like in line with the fraction bar so it doesn't look like it's in the numerator or denominator. But, 3/6 we could reduce down to a half. But like I said, if you put it as 1x over 2, that's fine. Just understand this is probably the answer you would see in a book. We'll look at part C. Same idea. If you want to just say we're going to divide each part of the numerator by 12. 6/12 is the same as a half. 15/12 you can leave as an improper fraction, but those can be reduced by 3. And so that would be 5/4 or 1 1/4. One thing about it, like I said, you can leave it as an improper fraction, but one thing is if you change it to a mixed number, sometimes it might be more obvious to you that you can reduce. So if I change that to 1 3/12, maybe those are more familiar numbers. They're smaller numbers, or at least the numerator is a smaller number, and then you might be able to more easily see that you can reduce that by 3. And part D. So part D, we can divide the 4 by 8. We can divide the 2x by 8. 4/8 is a half. 2 and 8 we can reduce by 2, which would be 1/4. If you want to put the x next to the fraction or in the numerator, either way is fine. So 1/2 minus 1/4 x, or 1/2 minus 1x over 4 would be our answer for that one. So this gives you a little bit of an idea on using distributive property. We will continue this in another video. Have a good day.